What should we get? So if you have 1 over x dx, integral of 1 over x dx is equal to log x. This is what you got to remember. Next example, if we have dy by dx is equal to x squared plus 2x plus 1. What do we do? Okay, we put integral for both sides. Right, and then we are using the distribution property, and also for the constant you can pick out for the integral sign. So you would get like that, right? So integral x squared dx. What do we get? X to the power 3 divided by 3 plus x to the power 2, or x squared, plus, what is the last term? X and plus c. Or you can do this way too. Can you do the separation of this term to be x plus something times x plus something? What do you get? X plus, okay, then you would get and what you can do next is just that you got to make this equal to this. Make it into the same term. So you know that dx plus 1 equal to dx plus d1. d1 is equal to differential of the constant equal to zero, right? So you would get only dx. So in that case, dx is equal to dx plus 1. So then you can say that now these two just look the same. You can assume that u is equal to x plus 1. Integral u squared du is equal to u to the power 3 by 3. And then your u is equal to x plus 1. Either way, you can use like distribution property like put the integral to each term there, or you can make it into this function and try to make the function here to be the same as the differential of the function, and then using the changing of the variable. Now, this one and this one is equal, in the sense that if you do distribution of this term, you would get x to the power 3 plus 3x to the power 2 plus 3x plus 1. Now 1 over 3 and c, both of them are constant. So you can make it as the c1, which is a constant. So at the end you would get x to the power 3 divided by 3 plus x squared plus x plus c1, which is the same answer as the one that you do individual integral, right? This is exactly the same. So in this case, you can use either way. You can use the first one, the first technique, that you just put the integral into each term, or you can look at it as a one function and then integral for the whole. It's up to you. So you can pick either technique to do the integration of this type of problem. Let's see other functions. What is this? Is 5, right? Next is 6, right? But if we have dy by dx is equal to sine x, just go to the trigonometry term function. We do integral for both sides. What do we got for integral sine x? Minus opposite. We know that differential of sine x by dx is equal to cos x, right? Cos x dx by dx, which is equal to cos x. That's what we know. And then also we know the differential of cos x by dx is equal to minus sine x, right? Now, you compare to the term. You have sine here. That side there is equal to d quart minus d quart, right? 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 The way that you do integral sine, you want to make dx to be d cos x. But we know that d cos x is equal to minus sine x. But this one you have plus sine x. So in order to get, you would put it with the minus cos x, right? Minus d cos x is equal to plus sine x dx. So when you do integral, you would get minus cos x plus u, right? Because integral du is equal to u. Integral dx equal to x. So integral d cos x equal to cos x. Now, if I have just do exactly the same, right? Now you know that this one, right? I just write down this equation again. Okay, make it in the simple way that you're using, that you will use. Now you know that d cos dx, sorry, cos x dx is equal to d sine x. So you just put it in there, you would get integral d sine x. Integral du equal to u. Integral dx equal to x. Integral dy equal to y. Now we have integral d sine x equal to integral d sine x equal to sine x. Next example. This is different from problem 7 in the sense that the angle of cos is 2x, but the differential is for dx. In this case, you just can't do this because if you want to do this, if you want to do this way, observe that, notice that this one and this one must be equal. But now this one and this one is not equal. How do you make it equal? Remark here. d2x equal to 2dx. Now you want to write down dx to be d2x. From this equation you would get dx is equal to 1 over 2 d2x. And then you just put it there, you would get 4 integral cos 2x. Now our dx is equal to 1 over 2 d2x. You just put it in there. 2 here is a constant, you can take it out from the integral side. You would get which is equal to 2 integral cos 2x d2x. Now this 2 is just exactly the same. What if I have assume u is equal to x? I would get 2 integral cos u du. Because you know that cos u du is equal to d sine u. So integral d sine u equal to Sine u. Can we just answer like this? No, because the problem statement didn't give you the letter u. But what the problem statement gives you for the independent variable is x. So you got to put u back into x, so you would get 2 sine 2x plus c. Any questions?